on some demon time.
No. Yesterday I walked in there, right, and I had like a flowing shirt on, and he was like, "Oh, you have a shirt that fits on today." And I was like, "Please stop."
Oh my gosh.
Anyways, the sass is real.
Okay, 44, unless anyone has.
Anyone has something below 44? We're feeling 22. Sorry. Oh, I will do it again, Jaway.
Jolly was swearing in physics. Yeah, I heard you. Jolly was swearing.
Megan's lying.
I'm sorry.
She's the imposter.
I'm sorry. What?
Whoa. 22.
Okay, I'm not sitting.
I. Wow. You heard it here first, folks. All right, 22. Ionic compounds. Why do they have a low electroconductivity as solids and high conductivity as in solutions when molten? How would you guys describe this for the first part?
Because when they're solids, they're actually
I would say when they're solid, right? The ions are stuck in place, right? When they're solid, the ions are stuck in place. But once they're dissolved or melted, right?
Yeah.
They're free to move. Once dissolved / melted, they are free to move. That's my version. I don't know what the book said. Yeah.
Okay, we're at full.
I don't know what else you need to write for that. II, relatively high in melting points. Why?
Lattice.
That's why.
Is it the lattice?
Lattice structure. Yeah.
Oh my.
It is hard to break that lattice structure for II. III, brittleness. So let's say I took like positive, negative, positive, negative, positive, negative. This is my structure, right?
Yeah.
And that was against a negative, positive, negative, positive, negative, positive.
You're gonna want to break one.
So, and then let's say I twisted that, right? If I twisted that, that's going to give me positive, negative, positive, negative, positive, negative. And that is going to line up with, if I twist this bottom part, now it's going to be a positive, negative, positive, negative, positive, negative. What is that going to do? It's going to repel and want to do what? Break. Yes.
And that's why they're brittle?
Yeah.
Because when you twist them, the ions?
Yeah. When you twist them, the ions start to line up, then there's repulsions instead of attractions. Okay?
Can I write that or do you want
Sure. I don't care how you do it. This is just my version of the answer. And then IV, solubility in polar solvents. So, in a polar solvent, right? Polar molecules have charged ends. Right? Agreed?
Yeah.
They have a positive and a negative end that can interact with ions. That's my version of 22. Cool?
I do not need to write a full paragraph.
Yeah, don't write paragraphs on the AP test.
Yeah.
We don't hate you. It's just that we have to read everything you write down. And if you write down something that's mostly right and then something wrong, you're going to get it wrong. Or the last thing you write is what we grade. So it's kind of weird. So write
I
down
feel like the rules for that are different for every AP test.
write down the most succinct answer.
Like, AP physics was like, write down everything you know and you'll get a point.
No, that's not what this is. It's not what this is.
Like something like the history content is like, if you just keep yapping for 30 minutes, you'll probably get it right.
That is, can confirm that's what I did.
Next one after 22.
30, and I did just like
37.
Yeah,
37. Which one correctly, or no, which of the following incorrectly shows bond polarity? So which one shows incorrectly bond polarity? So
There's multiple.
Wait, which one are we doing?
37.
Oh, okay.
The only one of those I got
I
was
think there's
D.
multiple incorrect.
That was the only one I understood.
D is incorrect.
so 37, first of all, D. Why?
Because there's no dipole moment.
D's not polar, right? That is completely non-polar. There should not be any kind of uneven charge, right? Diatomic molecules are definitely, that's the only true non-polar. What about
B.
B?
B is wrong.
Why is B wrong?
Because chlorine is like one of the most electronegative, and so it should have the partial negative charge of the ion.
Yeah, chlorine should have the more negative charge, and then iodine should have the more positive charge for B.
I think also E.
And then on E, which one is more electronegative? Oxygen. So oxygen should have the negative charge, and phosphorus should have the positive charge. That's it.
Okay.
On 37. Next question.
44.
He's feeling 44. Now I'm going to do that as much as I can, Jaway, because you like it.
I don't think it was like, I think I'm gonna go home, guys. See you on Monday.
Bye.
You have to get a
We'll miss you.
You have to get a new photo.
44.
Right.
The following represent CH4, NH3, or H2O. Label each and explain your choices.
Okay, the easiest one was CH4, like it's C.
CH4,
Yeah.
right?
I don't know why.
Because this is a tetrahedral.
Yeah.
There's 1, 2, 3. The fourth one's kind of in the back.
I think the top one kind of looks like water.
The top
Yeah.
one is water.
The top one
Because there's
is H2O, right?
yeah.
Here's my H plus, my H plus, and my O2 minus.
When it asked you to explain your choices, like what do you?
I mean, you can look at it. I don't know, like how,
I'm not explaining.
you don't really need to explain it. I don't think so. And then NH3, you can see here, you can kind of see, right?
Yeah.
There's the 3 H's, and here's the N. So that is NH3. That's
Make
NH3.
like the grooves a little more like defined.
I know, B, the picture wasn't as good, but
Oh, yeah.
the thing is on NH3, you really have a positive and a negative side. That's what they're showing, right? You have a lot of negative and then a little bit of positive.
Yeah.
Sure.
Yeah.
Like
I
if,
just need to know how to do
59. I just wrote in my book.
Yeah, I was about to say that, but
I don't care. This is actually like my actual book. So, I don't even think this one's barcoded. Nope. I own it. Because when you pilot it, they give you a bunch of books. And then I just keep the pilot books. And then I use those. So, all right, 59. Which compound in each of the following pairs has the most exothermic lattice energy? Well, remember, lattice energy is related to two things. Lattice energy goes up as charge goes up. And lattice energy goes up as distance goes how?
down.
Down. Because they're closer. More, I cannot think of the word. If they're closer, they have more attraction. There we go.
Is that Coulomb's law?
Coulomb's law. This is just Coulomb's law. So for A, I have NaCl and KCl. +1, -1, +1, -1. Are any of the charges different? No. Cl is also the same. Agreed?
Yeah.
So I have to figure out which one's smaller, Na or K.
It's an A, yeah.
There's your answer for A. Because Na is smaller, they can get closer, a stronger lattice structure.
What if they give you one with different shapes and different charges?
They won't.
Okay.
You will not be asked to do that. So that's A. Let's look at B is similar to that. Let's look at B is essentially the same thing.
It is. Okay.
The answer the answer's in the back of the book. But that would have been, which one is smaller? LIF, right? That'd be LIF. On C, I have MgOH parentheses 2, and I have MgO.
The O has the bigger charge.
Well, let's look at this. I have a 2 plus. I have a 2 plus. Agreed? I have a 1 minus, and I have a 2 minus. Right? Which one has the larger charge?
Well, there's 2 OHs, right?
There is, but it's still going to be the MgO
Okay.
because that's a larger charge. What is he doing? Like, what is he doing? There we go. I feel better now. D. I covered the microphone before I did that. We're done. We're not.
Scream off.
I have FeOH2 and I have FeOH3. Right? Oh, hydroxide's a 1 minus. Yes? This Fe has to be a 2 plus. This Fe has to be a 3 plus. Stronger lattice energy. Cool? You good with those now, Jack? Okay. That's 59. Next one.
So for C, which one has the bigger, like, lattice?
MgO.
Oh, you.
Because I got a larger charge.
Oh, yeah.
I'm in favor of 70.
I need to know how to do 61 first, because my math is not.
Okay, 61. So, for 61, I have K solid plus 1/2 Cl2 gas yields KCl, which is a solid. And I'm given several energies, right? My lattice energy is negative 690 kilojoules per mole. My ionization energy is 419 kilojoules per mole. My EA for Cl is negative 349 kilojoules per mole. Am I still on the screen? My bond energy for Cl2 is 239 kilojoules per mole. And my enthalpy is 90 kilojoules per mole. So we have to check all of these and make sure that these are good. Lattice energy, good. Ionization energy, good. Electron affinity of Cl. Do I have Cl here?
We have one.
Electron affinity of,
We have one.
On the right side.
wait a second, or no, is it the bond energy? We have to this is good because I have a Cl here. So I'm going to be forming a Cl. But here, the bond energy of Cl2, right? I only have half of that. So I have to divide the 239 by 2 before I add them all together. Then when you add those all together, you should get the correct answer. You should end up with negative 411 kilojoules per mole. So on those, you're literally just figuring out which one you have to change. Maybe we have to divide something by 2. Maybe we have to multiply something by 2. That's it. I can. Jack, you good with that now? Okay. So that was 61. Next one? 70? 70.
The last one we're gonna do today, right?
I mean, unless you guys want to keep going. Okay.
Oh, just yeah.
Not there yet.
That's fine if we don't keep going. Okay, 70, I'm going to start drawing this out. Am I good to switch the page, Megan?
Yes.
Okay. On numero 70, who thinks I got it? Who had no idea what to do?
I did it, but I
I did
kinda
it.
guessed.
Okay.
I think I got it.
So this is easier when you kind of look at what you're doing. So on letter A,
Yeah, I did. I think
I have H to C triple bonded to N plus 2 H to H. Are you okay with what I just did there? You guys okay with what I just did there? yields,
The coefficient, right?
yeah,
So, okay.
yields H to C to H to H to N to H to H. And we know that bond energy, right? Delta H is equal to bonds, the sum, right? Of bonds broken minus the sum of bonds formed. Right? Yeah. Yes? So I had to figure out what bonds did I break. So I have a C to H bond here. Was this bond broken?
No.
No, because I have a C to H bond here. Are you okay with that? I have a C triple bond end. Do I have a C triple bond end on the other side? No. So that's one bond that was broken. Do I have any H to H bonds over here?
No.
No. So I have two H to H bonds broken. So I have to look up those energies in the book. Which is what page? I forget.
323.
Yeah, 323.
Okay. So my C triple bond N, so my delta H, is going to equal 891 kilojoules per mole times 1, right? Because there's only one of those. Plus, I have, for H to H, that's 432 kilojoules per mole times 2. So that's my bonds broken. Minus. What bonds were formed? So this C to H was accounted for here. Agreed? This CH is this CH, right? So this bond was formed. I have one CH that was formed. I actually have two of those. I have two CH bonds.
Yes, you see.
Agreed?
Yeah.
I have a C to N bond that was formed. And I have two N to H bonds that were formed. So I have CH times 2. I have C to N times 1. And I have N to H times 2. So you just had to figure out what was made. Cool? So minus C to H is 305 kilojoules per mole times 2 plus C to N, wait a second, did I do this wrong? C to H is 413. Sorry, that's 413. 413 times 2. C to N is 305. 305 kilojoules per mole times 1 plus N to H is 391 kilojoules per mole times 2. And then you just have to do the math.
What is the answer coming to?
Should be negative 158.
I
Negative 158.
added up every single bond on the left and subtracted every single bond on the right, and I still got negative 158. Like, I think I had the only difference is that I included the HC on the left, and then I had 3 HCs on the right, so it just turned into 1 minus 2 instead of 1 minus 3 instead of 0 minus.
That might be lucky.
Okay, I won't do that then.
Don't do that.
You have the right answer with the wrong process.
Yeah.
Close-ish.
It might work, but I would really do it like this. Yes. Do you want to know what the answer should be for B so you can work that on your own? So for B, you should end up with negative 1169 kilojoules. Also on B, everything is broken and everything is formed, right? So you have more work to do on B.
Yeah, that was fun.
So Monday, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of those 9, only 1, 2, 3, 4 you can't see the answers for. So hopefully Monday, it'll take about half the period at the most. And then I have a couple Kahoots we're going to run as well on Monday. The practice test is up here. Here's the practice test. Answers are here. You guys have the rest of the period to work on whatever you guys need to. If you keep working, have questions, I will answer them.